All right, so we are going to continue on our trigonometry journey with our next topic, using tangent ratios to find side lengths. All right, so say we know our angle and say we don't know either the opposite or the adjacent side. That's what we're going to look at doing today. We're going to start off by warming up our fraction part of our brain, which we all love. And we're going to recall what we do when we solve proportions, right? When we have something equal to a fraction or a fraction equal to a fraction. What we want to do is we want to cross multiply to remove that denominator, right? Essentially, I'm multiplying both sides by those denominators so that we see that common factor and they cancel out. Okay, we cross multiply across that equal sign. So let's do a couple of proportions just to practice. So I have 2/3 equals x over 7, right? I'm trying to find an equal proportion, right? How many sevenths is equal to 2/3? Well, easiest thing is to get rid of the fraction, so I'm going to cross multiply. I'm going to multiply the 3 onto the right side, and at the same time I'm going to multiply the 7 onto the left side. Right? That gets rid of the fraction of the 3 from the left, as well as the fraction of the 7 from the right. So multiply this side by 3, and I multiply this side by 7. So what I have left on the left side is now 7 times 2. On the right side, I have x times 3. Well, I get a 14 on the left side and a 3x on the right side. I divide both sides by 3. Right, that tells me that x is 14/3. Right, we can leave it as a fraction. If we really want, though, we can turn that into a decimal, and it looks like 14/3 is 4.6 repeating. Right, so 2/3 is the same as 4.6 sevenths. Let's look at the next one. Right, same idea, but this time we only have one denominator, so we're only going to cross multiply in one direction. Technically, this is a 15 over 1, right? So I could multiply the right side by 1, but we know that's not going to change anything. So I have 15y on the right side is equal to just 60 on the left side, right? Essentially, that's me multiplying both sides by y, but because I'm multiplying, it cancels the y out on the right side. Divide everything by that coefficient now, and I get a y value. 60 divided by 15 is 4. All right, so 15 is 60 over 4. So if we remember, right, our tangent formula, it has a ratio, it has a fraction, specifically that we're looking at how the opposite compares to the adjacent, right? All for one specific angle that we call A, we call theta, right? A lot of different things. So these formulas are just proportions. If, say, I had an unknown up here in the opposite side, right? That's just like our first example. We're going to cross multiply and then I can solve for x. Say I have an unknown in the denominator. That's just like my second example. I'm going to cross multiply and then divide. Right, so we're going to use these ideas. We just have different functions showing up. We have variables, we have tangents, right? So let's look at some examples to get a better idea of this. So let's find the length of rs to the nearest tenth of the unit. So in all of these, it's talking about the length of the side that runs from point R to point S. And so we see something a little bit different this time. Right? We're given an angle. This is where it also becomes super important that we label our sides first. So because we're given this angle, this is what we're going to use as our reference angle. So when I label my opposite, adjacent, and hypotenuse, hypoteni, who knows? I'm going to be referencing this angle. So opposite is going to be this 15 centimeter side length. This is my opposite side length. Right? Remember, we're talking about the whole side length. This is the opposite side length. My hypotenuse, opposite that right angle, right, the longest side. And so my adjacent, in this case, is length RS. Right, and let's call that, we can call it X. We can call it RS, we can call it whatever. Let's call it X for the sake of solving. And so when I'm creating this, right, I know my opposite side length, and I'm trying to find my adjacent. So that brings us back to that idea of the tangent ratio. Right, tangent is the opposite over the adjacent. Has nothing to do with hypotenuse. I don't know my hypotenuse in this triangle, but dealing with tangent, I don't need to, so that's okay. So I'm going to fill in the blanks here. Right? Things are going to look a little bit different this time. I have my angle of 35 degrees. That's going to go inside that tangent function, right? I'm taking the tangent of 35 degrees. I'm saying, how do these two side lengths compare when I have a 35-degree angle? And then I'm going to fill in my opposite. So this time my opposite length, I know the value, it's 15. And my adjacent length, this is my unknown this time, right? This is that RS, right, or what we called X. So that's going to be what I plug in for my adjacent. I have to have one unknown somewhere, right, or else I'm just giving you a statement, right? If we're solving a problem, we need to find something. So here, I want to find that X value. Now, just like before, right, I'm solving a proportion, especially when my X is on the bottom. I'm going to cross multiply, right? Multiplying technically both sides by X, but it disappears from the right side, right? I have an X in the numerator now from that multiplication that undoes that X in the denominator. But I have to bring an X to the other side. I now have X times tangent of 35. But now that's equal to just 15. So now to get X by itself, I have to divide by whatever it's multiplied by. Right now it's being multiplied by the tangent of 35. I'm not doing any inverses here because now I'm not trying to undo that tangent operation, right? I'm just trying to undo this multiplication here. So I'll divide, right, just like we have before. I'm also going to divide the other side by tangent of 35. And so my X value, that length, right, length RS, is 15 over tangent of 35. All right, well, tangent of 35 is a ratio, and we can find that using a calculator. So I'm going to pull up my scientific or my graphing calculator. All right, I'm going to take the tangent of 35. All right, so that's my denominator, 0.7. That's just saying, right, for a 35-degree angle, my opposite side should be 0.7 times my hypotenuse, right? The opposite should be smaller than the hypotenuse. So when I'm doing this, right, I had 15 divided by tangent 35. You can type in tangent 35, right? Make sure you're using some brackets if you're using a graphing calculator. Or you can type in divided by this number that we just calculated. Either way, this time it's giving us length X, right? This is not an angle. This is length X. This is the length of this red line, right, this bottom side. And so our X value, we'll round that to the nearest tenth. Let's go 21.4. And our units, centimeters, right? Nearest tenth of a unit. Right, so what this is telling us is for any 35-degree angle, if the opposite length is 15, the adjacent length is 21.4, right? For a 35-degree angle, the opposite length is, like we saw, 0.7 times the adjacent length. And so we can use that to our advantage. We now know length RS. So let's try it again for another triangle. All right, so I just made a little bit more room. This time, again, that same idea. Using this angle as my reference angle, let's always start by labeling our triangle. Get into a good habit of that. So the side length that's opposite, right here, that happens again to be length RS. That's what we're trying to find. We can label that with a variable if we want. Our hypotenuse is opposite this right angle. Right, it's the longest side that happens to be on the bottom this time. Again, we don't know this side length, but we also don't need to know this side length. And then this 24, it's the length right beside our angle that isn't the hypotenuse, right? It's our adjacent side. So setting up our ratio again, same idea is happening here, right? I want to know the opposite side. I have the adjacent side. So we're going to plug that into tangent, right? We don't need anything to do with the hypotenuse this time. So the tangent of our angle, right? Our angle is always what goes inside the function. We can't put a side length inside a function because then it's not telling us a ratio. So the tangent of angle 48 is opposite on top. This time the x is in the numerator, so a little different compared to last time. And our denominator, our adjacent side, is 24. This time it's actually pretty easy to solve for x. If I multiply up this 24, right, I cross multiply by 24, I get 24 times the tangent of 48. And my x is already isolated. So this is saying that if I take 24 times that tangent ratio, it's going to give me my opposite side. So again, pulling up our calculator, 24 times tangent 48, right? Close your brackets. And it tells us 26.7, right? Round up because the next digit's a 5. This time x is 26.7 inches. Let's try a couple more. So you try, pause, see if you can use that tangent ratio to find for each of these side length RS. So from point R, right, vertex R to vertex S. So this is our unknown in triangle C. And in question DRS, this is our unknown here. So take a minute and give those a try. All right, so for question C, same idea, right? I have my angle. I'm going to label my sides. I always label my sides to start. Opposite is on the opposite length. Adjacent is touching, but is not the hypotenuse. So the tangent of our angle, this time we have a pretty small angle, right? 15 degrees. Now a lot of these times, just note that these triangles might not be drawn to scale, just because the limitations of technology. So even though it doesn't quite look like 15 degrees, we're going to go with the numbers rather than what we're seeing, right? Because we're not actually using a whole lot of measurement tools in this unit. We're using the ideas behind the algebra. My opposite goes on top. It's an x on top again this time. My adjacent, 25 centimeters, goes on the bottom. Right, I'm cross multiplying, or another way to think of it, right, I'm multiplying by 25 because right now 25 is in the denominator. If I bring a common factor into the numerator, they cancel each other out, right? They reduce. But that makes the left side 25 times bigger as well. 25 times tangent of 15 is x. Plug that into our calculator. 25 times tangent of 15. Or if you want to do it in 2 steps, do the tangent of 15 first, right? If you'd rather work with decimals. And then multiply that. Again, making sure you're using, if at all possible, that answer button. Oops, sorry, times 25. Let me try that again. 25, there we go. 6.7. Right, so notice that we have a really small angle here, right, 15 degrees. So it's actually going to produce a much shorter side length, right? Our opposite is much smaller than our adjacent. Right? The smaller an angle you have, the shorter of a line it produces, right? So that's talking about our opposite length. When we see really small angles, our opposite should be much smaller than our adjacent. When we see really big angles, our opposite might be smaller than, right? Or sorry, equal to or bigger than our adjacent. And let's work through the last one. Again, right? Always labeling our sides in reference to whatever angle we're given. If we're given multiple angles, we'll choose one. But here we only see one, so that'll help us label our sides as opposite, hypotenuse, and adjacent. Right? If you're struggling with this part, let me know. We can go through some more practice on that. So using our tangent ratio, again, these will all be using tangent. We'll see what other ratios we have in the next unit, or in the next lesson. But here, everything's involving our opposite and our adjacent. This time, right, 403 is our numerator, that's our opposite side. X goes on the bottom. Right, when our x is on the bottom, it usually involves a couple more steps. Right, I cross multiply that x. So then I have x times tangent of 31 equals just 403. Then I have to divide again, right? So a little more work when that x is there, because now I have x being multiplied by something. So a lot of the time you might hear this method called cross multiply and divide, right? Cross multiply and divide. So we cross multiplied the thing in the bottom. Now we divide by whatever was beside our variable, right? What we were trying to find. So really, whatever happens, we're always either just multiplying or dividing this tangent of our angle, right? If you look at question C, we had our unknown side multiplied by our angle. In question D, we have our known side divided by our angle. So let's plug that into a calculator. 403 divided by tangent of 31. And it tells us 670. Right? This time the adjacent side a little bit longer than the opposite side. So x equals 670.7. And this was in millimeters. Right, so these are all of your side length RS's here. Really, two possible options, right? There's only two ways the algebra can get tricky. So if you can practice these ones, right, you could do any trigonometry question. Let's apply it to a real problem. So a searchlight shines vertically on a cloud at a horizontal distance of 250 meters from the searchlight. The angle between the ground and the line of sight is 75 degrees. Determine the height of the cloud to the nearest meter. So trigonometry is actually a really useful tool for determining the lengths of things that we can't measure. But if we can measure things around it and create a right angle triangle, we can use these skills, right? Figuring out how tall a tree is, right? As long as you know how far away from the tree you are and how high you're looking up at that tree, right? You can figure out how tall a tree is without climbing all the way to the top. And a lot of software uses the idea of trigonometry, like the measurement app in your phone. And it can use that idea too to estimate lengths. So we have our triangle here. Again, we can draw it out again if we want. So we have our searchlight, right, which is what they're trying to find. Determine the height of the cloud. So when we say height, we mean vertical distance off the ground. And so our cloud's up here. And so this is our unknown, right? Our height from the ground. This is what we're trying to find. That can be the trickiest part in a lot of these, is figuring out, what am I doing? Which of these sides or angles am I actually looking for? It tells us at a horizontal distance 250 meters from the searchlight. So we are standing right here. Here's us. 250 meters away. So this length here along the ground is 250 meters. And the angle between the ground and the line of sight, this is often called the angle of elevation. This angle here is 75 degrees. Right, so you're looking up at a 75-degree angle to look at this cloud, to look at where the searchlight hits. So, labeling our sides, again, this is going to be the start to every single one of these. You're going to get really sick of me hearing the words opposite, adjacent, and hypotenuse. It looks like our unknown side is the opposite. Right? If you're ever struggling, remember that vertical and horizontal distances, right, the ground and something vertical always creates that right angle for us. So that can help us find our hypotenuse. And then our 250 meters, that's going to be our adjacent, right, because that's the length beside our angle of sight. So same idea here, right? As we did in the last one, all we've done here is thrown in a picture of a cloud and a picture of a person. Right? It's still a triangle, still the same math. We want to figure out, what is that opposite side length? We know the adjacent. Well, when you think opposite and adjacent, you think tangent. So tan theta, right, is opposite over adjacent. Always helpful to write that out so you don't forget. Tangent, now substituting in our values, our angle, well, the only angle we know is 75 degrees. And the opposite length compared to that angle relative to angle 75 is our unknown on top. We're going to call that x. And our adjacent on the bottom, that one had a measure of 250. Right? I'm cross-multiplying that 250, or I'm multiplying both sides so that it goes away on the right, but the left side had to get 250 times bigger to compensate. So 250 times tangent of 75. We just have an x, right? We've isolated our variable. Now we just pull open our calculator. 250 times that ratio times tangent 75. And it tells us 933. And we'll round that to the nearest whole number since it's a 0.0 anyway. We check our units, right? We were talking about meters. And so we say the cloud is 933 meters above the ground. Right, so we can find distances that we can't measure, but as long as we can measure some surrounding values, right, create a right angle triangle, we can kind of figure out, right, these unknowns. So that's where we're going to leave it with tangent. When we come back in our next lesson, we're going to look at sine and cosine, right? Our other two trigonometric ratios, we introduced them at the start. We're going to see what two sides they might be comparing and how we can use these exact same ideas to solve some problems when we might not have the opposite or the adjacent or both. So email your teacher with any questions, right? Stop by your class.